presentation this afternoon. We'll start with Claude Acket, then Sandra, Bruno, and then Georg Hermann, is here. And so Claude sent a mail about a month ago saying, well, could I give my presentation in French? And so we thought about that and we said no. And so he worked, I understand, he worked quite hard and he improved his English for the past month tremendously. So we'll check that now. So Claude has been working for a few years now on a scenario for France, factor 4, CO2 reduction, for an association which is called Save the Climate, and you find this written black on white here. And now he will explain all about that. Claude.
Thank you, Jack. I'm sorry, but I stay sitting during the presentation. So I don't begin with this generality. It has already been made this morning. The increase of population, the increase of needs of energy, probably a factor 2 for the middle of the century. The problem with the fuel, the fossil fuel, the risk of greenhouse effect, and so to limit this, we have possibilities, efficiency, and renewable or nuclear. And negative characterized by more nuclear. So when I presented in the last the debate in France about those 50%, I immediately say, I agree with 50% of the president, but for me it is 50% more of nuclear. So you will not be surprised. In fact, the scenario negative was already presented during the debate on the first large debate national in 23, and under the name Draw Out of Fossil Fuel. Sortir des fossiles. It was the name, the first presentation. In 27, inside the association Save the Climate, Sauvons le Climat, it was studied again in detail, and then it was presented under the name NEGATEP, TEP for ton oil equivalent. So the same objective, grow out more possible of fuel, fossil fuel. With another significant is that when we use TEP, we need energy. Energy can be named in joule, in water, or in TEP, but we never use the term watt. We don't mix energy and power. So marks energy and against fuel, fossil fuel. So the generality as here, and I just recommend this 3 lines, which explain the following presentation. Thanks to nuclear, France already made a part of the way. In fact, with nuclear, France has way out from coal. And it's this way that we want to continue with the negative. But it's not, today is not sufficient, as we'll see immediately. And so we go further, and with an objective to go close to factor 3 or 2-4. Alors, why 3 to 4? Because, as we will see, the famous factor 4 was presented during the debate in 23 for the first time, but it's 4 for the whole, for the developed country, for Europe. It will be normal to have, for instance, 3 for France and 5 for Germany. And so this is evident when we see the today's situation of of the primary energy, distribution of primary, France, and comparison with the world, with the importance of fuel, of fossil fuel in the world, much limited in France because the coal practically disappeared. But it is not evident to compare France and the world, and so we make a comparison between France and Germany, and we immediately see the difference of the emission per inhabitants between the two, a factor 50% more in Germany than in France.
What is the year? In which year?
After the first diminution of nuclear in Germany. It is practically Germany today. So, if we to prepare the future, it is interesting to go in the past and to see the movement. And in the past, if we start before the oil crisis, we can make we can see the liaison between the gross production. France, it is the gross domestic production, the consumption of energy, and the emission of gas carbonic. And we can see the influence of oil crisis on the world domestic production, on France, like in the war, but France domestic, the influence on the consumption of energy, and with the stability, new increase because the oil crisis is past. And the question is now, what are we doing from now in the future? If we continue, and you know that each government hopes that gross domestic product will increase by more than 1% a year, 1%. In that following, we see that we have to make effort to lower the increase of energy through sobriety, but sobriety means effort of each one and more efficiency. And then, if we look at the gas carbonic reject, we can see the influence of nuclear in France, a drop, due to electricity nuclear in place of electricity from coal, not exactly from coal, in part it was also from oil, because France in this year, the electricity was produced through oil, and oil was replaced by coal, and definitely it was nuclear and practically no oil, no coal in France. And then we see that we have to go further, so more nuclear and more renewable. So the first objective, and I will say the only objective, we don't agree with multiple objective. For instance, the 320 for 2020. It's very interesting for the journalist, for politician, but there is no sense, because we can go through the three together without contradiction. So we have one objective, is a reduction of the gas reject. For this, each country can do through less energy. What energy? Is it final? Is it the primary? If we look about the reject, it is more than about the primary energy, not the final energy. Then we have to look about, it is not interesting to fix one criteria, but only one is the gas reject. So we have to look where the producer of gas carbonic in France, and we have, in fact, we have what we call the stationary use. In the stationary use, we find the housing, large the housing, but it is not only the housing of people, it is also the tertiary domain, the shops, and so on, and also to all the shops, or so on. So the stationary, and then an important factor domain is the transport. And if we look at what the characteristic in France, the electricity is very limited. So to go to the fourfold reduction, we have to focus on these two through energy conservation. What in France we call sobriété. I don't think that the word sobriété is used generally only for the drink, but sobriété. So energy conservation, that means less service to the population, and energy efficiency, that means for the same service, less energy necessary. And use then, after this energy reduction, use other source of energy, especially renewable only for heat. We insist of renewable for heat. And then more electricity in the conditions that electricity will be produced by non-carbon sources as renewable and nuclear. So this is the basis of the negative are clear here. The priority is gas carbonic reduction, and the second criterion is also the control of price, because in step of the argument we have to decide where we put the money. Should we put it, for instance, on the insulation of the housing? Where do we go to limit the consumption? And then we have to be very kind about the control of price. Then we have to look also the security of supplies. And one thing important is the worst is the lack of energy. If we have a large problem of lack of energy, it will be probably the worst, more than some war. It was inside so different country. So with this criteria, we study more in detail improvement of efficiency, and we increase the share of electricity vector in the condition that it was produced without carbon. And in this direction, we see that there is a solution. It's to improve nuclear. So directly to the final, then with time I will go more in detail. So from the today's situation, we look at the three vector of consumption: residential, tracer, industry, and transport. And we see what will be the tendency, which take account of the increase of population. 18% for France, it's different from Germany. So we have to take account the increase of population. And then more for each inhabitant, because of a lot of events to take on. The aging of population. With the aging, we need more temperature in the housing. We need more surface per inhabitant. There is also problem of society with the dispersion of the family and so on. So there is a natural evolution tendency which go to increase per inhabitant. That is a tendency. So we have to go against this tendency, but we think in negative, we push more on the efficiency than less service for each inhabitant. So major accent is on efficiency. And so with this, we can see that from if we part from the year before the two-day crisis, we see that we decrease for each domain of consumption, except one, but it is very particular, it's the transport, which in fact needs an increase of industry production. That is a problem which appears in practically all the scenario. It is in fact the consumption, the intermediate consumption, which are often forgotten. We present generally only the final, but in the middle there is a lot of intermediate consumption, and where we have to put them. We chose to be clear, not to forget them, and so we affect, because we go more and more for transport to electricity and biofuel, we need more and more consumption in the industry domain. So it is what we found this small. Obviously, if we forget this one, we can say that, oh, it's wonderful. We have a decrease. We have decreased for 40%. The final. So in fact, for instance, if we look at the classment presented by Patrick Schrick this morning, we are sometimes deconsidered because we don't decrease not sufficiently our consumption, but it is a matter of where we put the intermediate consumption. So this is the final view. So now we go. I don't cover here all the items. One interesting is this of the heating of housing. It represents about 28% of the world consumption. It's not the major, but it is 81% of them. And the question is, till what level do we go for the insulation, and essentially to what price? What will be your price? And we don't go very far, and we limit the. If we consider that the two-day consumption is 210 kilowatt per square meter per year, it is the mean. In fact, some are more than 300. The maximum is about 400. But if we consider it, we think that we have, for the new construction, we propose to decrease to 50, and for the renovation only to 100. Why? Because there is a general rule that if we want to decrease by a factor 2, we have to put a sum of expenses. If we want to gain a new factor 2, we have practically the same expense, and so on and so on. So there is an explanation, and go to near zero will cost a lot of, will be ruinously. So we limit the depends, and this we can see that, for example, for the renovation, each year, if we want, for instance, to go very low, we have to spend twice what we intend to spend in the case of the negative system. But this is in fact not so important if we arrive to limit the consumption with no gas carbonic emission. And so if we increase all the biomass in the house, a part of solar heating, but mainly for sanitary. If we use it, especially if we use heat pumps, which is the basis of the Negatep scenario for all the housing, it is a heat pump. Obviously, heat pumps means more electricity, which a few years ago was not admitted inside some of French administration. Heat pumps was horrible, but now heat pumps seems to have to become more in favor for the same administrative organization. Well, just a word about industry. If we look at how industry, in fact, industry is a domain which has improved most its efficiency as a consequence of the oil crisis. And it's evident because for industry, the price is a motor of all. So with the oil crisis, we can find the difference improvement in efficiency. First improvement, which can be made very easily. Then other improvement, which need investment. But we can, for instance, we can see that the best improvement occurs when the oil crisis is always finished. But anyway, it was made. And then we have a stabilization, and now can we increase the efficiency of the whole industry? Important, the easiest was done. For example, the recuperation of residual heat, the modification of all the motorization, the speed, variation of speed in all the industry and so on. So all this is practically being made in practically all the industry. So easiest has been made, and we consider that only half the same amount can be made. But one characteristic of the industry is the tendency to go progressively to electricity. Oh, it's easier for industry to say that the problem of environment problem are not in their domain because they come from electricity. So more and more industry think it's better to use electricity. But it is true already for the elaboration of raw material, more and more electricity for raw material, even for steel. So, but in fact, the main modification in the scenario negative goes to the transportation. It's obviously because today transportation is obtained through oil for practically 100%. So we can speak about the management of mobility, but we don't have to move all the village to town and so on. It will take a long time. So we think that we have to continue with our system, improve the mass transportation around the town, but the problem will still exist practically with the same amplitude for the totality of transport. So technology progress are feasible in the continuity, but the most, as I always explain, it was the replacement of oil by electricity, either directly, and we think about electric car, but also for plugging hybrid car, not the today plugging, not today because already we find the plugging, but very limited. But in fact, the development of plugging in hybrid car and indirectly, what is one of not originality, but we think about very intensely about this in Negatep, is use the electricity as a possibility to increase the possibility to produce biocarburant with the same quantity of carbon, natural produced by the nature. And for this, obviously, it's the end of the first generation of biocarburant, and we go to the development of the second generation with, on basis the thermochemical way, the famous Fischer-Tropsch solution, and so with the use of electricity, we can produce this quantity of fuel. This quantity of fuel can be used for the transport. Then we arrive to the part of renewable in the general picture of energy. So, at first, all is perfect was renewable. They are all the virtues. In reality, they have their limits. For the wall, the limits we can be estimated to a factor of 4. There is the only difference between France and Europe and the rest of the world is the electricity, is the hydroelectricity. In France and Europe, practically all has already been made. For the world, we are sure that electricity can be multiplied by a factor 3 or 4. So for France, Europe, practically no modification for electricity production. We'll see later more detail, but there is a difference. But for the other source of renewable, biomass and so on, it is the same, France, Europe, and the rest of the world. It depends on geographical situation, obviously. So, but there is if it's all other virtues, one of them is it's not gratis. It costs a lot because of investment. And so we put the priority on heat generation through biomass, solar heat. We are very prudent with biofuel because there is a competition in the use of the land. And the major problem is the electricity storage, as we can see later. So just to show that we not neglect the renewable, and practically we propose the same development as other scenarios which are more considered because there are other virtues. In fact, for the heat, so we multiply by practically a factor 4 the utilization of renewable heat in our scenario through biomass, so thermal energy, especially for heat sanitary water. In our scenario, all the sanitary water will be made through it, with a law for new building and progressively introduction in the older one, with obviously an help when there is no sun with electricity, but it will be specific electricity during the night with, as we'll see later. So for geothermal, the main production comes through the heat pump. It is geothermal, either the real geothermal or the surface, what we call the geosolar geothermal, even with the air atmosphere geothermal. This air atmosphere is the best for innovation of old houses. So we have to be. We say we have to be careful with the use with the biomass, because we have to be careful with the use of the land. because there is a competition between transport and also the other utilization of wood to construction and so on. So in our scenario, we practically not modify the today situation in France between two mill, the grass, and the forest. Practically, we don't change. We don't change. We don't accept in our scenario to cut what each French will eat as meat and even more dryly, because there is some scenario which is they decide that in the future we'll eat twice less meat. It will be good for our health, they also say, but I don't think that it will be accepted very easily, but more also twice quantity of dry dairy. So I don't think it's good for the health. Anyway, so we practically no modify. We can improve the efficacy in the utilization of grassland, but not very limited. So there is no few modifications. It was distinct this scenario from other one. And then we can, the most important is the main use of the forest. We can, in 10 or 20 years, multiply by a factor 2 the utilization of the forest for energy sector only. It's very easy. And we go further, but we go further, we have to specialize on specific plants. And for instance, but there is not, it is not only one, there is one new generation plant. No, for instance, the miscanthus, which is very good for production of dry mass per hectare. It is so with all this in mind, we can obtain a total of this quantity, and in fact, we have some margin in comparison with our need. Then we come to the electricity, and then it is a domain where there is more controversy between different scenarios. For the hydraulic, we don't see a lot of modification. On Earth, practically all has been done. We must thank our ancients, because if we have to begin again, it will be refused in all the country. So thank you, it has been made. Now, there is a small possibility in the improvement of today's installation. Then for the marine, we are very pessimistic about the marine development. We see that we have already tried the tide without success. It must be seen it was a disaster. The tide without following. The tests about the wave are not in a good way. Rest only the undercurrents in test, but we are sure that every time we use sea, in sea there is salt, there is corrosion, but we discovered it was that with undercurrent there is no problem, which is the erosion from sand, because with the current comes sand, and all the experiments made, especially in Canada, was a disaster. So perhaps we can have some hope for the tests, which are it is only the only way in France with some tests, but with optimistic, it will stay limited. Then we come with the two domains, very contested, solar and wind. And for the negative, we change the diffusion of negative scenario. between 27 and 28 because we take account of the Grenelle de l'environnement, of the Grenelle, which decide to impose for the year 22 a small amount of solar and wind. So we improve the quantity of solar and wind in our scenario, in the depends of the gas emission, because with more wind and solar, we have more gas as a background solution for electricity. So we take, because there is a law, we accept this law. Perhaps in 1920 we'll see that it is not impossible, and then we say it's a good new. We don't go till this value. What we can see is we don't forget how the electricity is used today in France. It's here you have, for instance, a day in December, and then a day in autumn, but without heating. First, we can see that the famous peak exists also in autumn. Is not the famous peak is not completely linked with the central by electricity. So this peak exists. And how today can we go with this variation? We use, in fact, all the producers act daily. And this is a mean variation for each of them. First, we have the hydropower. Then we have nuclear, fossil, and also we use on the export-import. So we need this variation each day. What's the problem? If we had this producer, it's the wind, which came when we don't need it, which is not there when we need it. And so this is a view we can have, for instance, in France, we can have a few days with a lot of wind. Then we can have 1 or 2 weeks without practically wind. And so, if we have more and more wind power, this needs more variation of fossil or nuclear or the electricity storage. There is also, we often see that there is no problem because we can use, when there is no wind in France, there is wind in Spain and wind in Germany, or it's completely false, because when there is a period anticyclonic, there is no wind anywhere in Europe, and the liaison through the grid is not effect. And when there is two wind, there is two wind altogether. And if each country goes to increase its power, there will be no possibility to go to the neighborhood which will have the same problem. So the development.
Excuse me to interrupt, but I did not get precisely the point of the previous slide, and I think it's very important because naively I would have thought that when there is some wind in Brest, there is no wind in Perpignan, and that you might make a compensation between these two areas. So you explain basically the opposite of this?
No,
when there is wind somewhere, there is wind everywhere?
No, this is, for instance, in France. Yes. We say in France, there is you can have in France, in fact, Sunday wind in Brest, no, wind in the south of France, when there is Mistral, and the winds in the north of France. So, in the mean, this is the whole production in France. But the opposition says, yes, but there is no problem, because if there is no wind in France, for instance, during anticyclonic, in fact, we will be helped by the wind from Germany. But there will be no wind in Germany, as this is shown by this view, which adds all the production.
So can you detail what we see on that curve to really be...
We have the...
because it's counterintuitive, in fact. To me, it's counterintuitive. It's not easy to accept that there is wind everywhere in the same time. So can you detail what we show?
In fact, we have the measurement of wind in different countries today.
Instant of time. Okay.
Yes. And we had at the same time, at the same hour, but the work was made by Hubert Frochard, which we presented in 1 or 2 days, the detail of this. So,
maybe you can come back in the discussion about that.
Yes.
So in fact, for the scenario negative, today we say there is no possibility of significant electricity storage. But in fact, we use the battery not for storage electricity to send it back to the grid, but only to charge the battery especially during the night when we can see during the night we have the consumption is very low. So with this we can erase a lot of variation of electricity need. So if we add all the possibility of renewable, we arrive to this, and it is an important increase of renewable. But if we look at the other point, we think that there is a gap to occupy with nuclear and fossil. So nuclear, I don't intend to speak about the second part for or against the nuclear. I just say we use this presentation, this part, to remind that we have today a lot of reactors in service. The holders of them approach the 40 years of operating team, but for the newest, only less than 20 years. So there is a lot of time. So in scenario negative, we think that we have to base our scenario on a prolongation of increase of life between 50 and 60 years in the conditions that the safety authority will accept it. We don't intend to stop all the reactors at the same 50 years because we don't want to repeat what was made in the years 80, at the beginning of the years 80, when we have to start at the same year, 6 reactors, the same years. So I was in charge of the start of the reactor, and we have at the same time 6 teams on the plant. It was not very. We don't want to begin again these experiments, and so we have to enlarge the time of replacement between 10 and 20 years. But then, so we engage the third generation, which will be from the beginning prepared for 60 years. But I am sure that when we see the reality, 60 years will be easily 100, a century. We will have the same problem, the same possibilities as today. When we see the real life of a reactor, because there is always such a margin between the theoretical definition on the specification at start and the reality of life of a reactor, that we have a lot of margin of it is a situation, today's situation in France, to pass from 40 to 50 and 60 years. We have in mind that in the United States, already a lot of reactors have the authorization to go to 60 years. So, at the future, but we have to prepare in this century the future, and for instance, we arrive to the fourth generation, and we speak about Astrid. No, so here you can see how we see the future of nuclear in France. So, increase. So we stop progressively the 2D reactor between 50 and 60 years. Then we have the replacement by new third generation. And then at what time we have to decide if we continue because we have sufficiently uranium to use the third generation, the 2D fission, or it will be preferable to go directly, to go to the fourth generation before the end of the century. But it is not a French problem, it is a world problem. It's okay, excuse me. Okay. So, general view for Negatep. For the main sector, we can see for residential how we decrease, and for each, we can see the importance of renewable heating. Biomass, wood, solar, geothermal, and so on. The same for industry, but a particularity for industry, we had these two. It is for the fabrication of biofuel. Industry use biomass and use more electricity. It is intermediate production. We have to take account some way. And so we have a very decrease of transport, but in fact, we have to add the modification because of the electricity. Let's say, to simplify, that a motor electric is the efficiency of 3 orders than a thermal one. So we have this is essentially due to the increase of use of electricity. So I passed. So this is the final primary. Now I come again to the primary production. Today, the part of renewable, with a distinction between thermal and electricity, and the general view about electricity, a forced increase of electricity, renewable electricity, but not sufficient, and just for the joke. In fact, the nuclear power installed is less than 50 power of the total installed in France. But I don't think that it can be an argument to give to the president. The last item, important, but perhaps the most important, is to see the price. What does it cost? And just this one, how the price, and we make a comparison between what we call the statu quo. That means we don't change anything today in spite of the increase of population. We stay in the same state. But for it, we have to spend money. We have to spend money for fossil, because if we continue, we spend fossil. Then we have to, if we continue, we have to replace some nuclear power too, but not more, and so on. And so if we make a comparison, then if we make a comparison with business as usual, that means that we continue to increase what we give to each inhabitants, and then the negative. And so, conclusion, negative costs 28 billion euro per year compared to the statu quo. So we have to spend money. So it was a cost of the negative to decrease the amount of reject of gas carbonic. We have to spend. But this extra cost can be come to zero if the fuel increase, but very important, practically must double, or if we add a combination of tax on, for instance, on gas carbonic and increase of the cost of fossil. So I finish with this, and this is a general view of the negative comparison with the business as usual and negative. So we have a division by about 4 of fossil fuel, multiplication by 3 of renewable, but in fact twice more electricity. And the electricity is the main factor for the robustness of the scenario. Thank you for you.